Call me weird, but I'm actually having fun doing these FRQs. So this is 2010 BC number 5, and we're doing part A, Euler's method. Start at x equals 1, 2 steps of equal size to approximate f of 0. Show the work that leads to your answer. So we are given f of 1. F of 1 is 0. And we're actually going backwards. So delta x is actually going to be negative 0.5 because we're trying to get to 0, and it'll take 2 steps of negative 0.5. So let me draw. Yeah, let's do it now. I'll draw freehand because I am so awesome at drawing. Freehand. Sorry, I know you guys are jealous because I just write such beautiful tables with my freehand. That's going to be x. That's going to be y. This is how much our x changes. This will be our dy dx at that point. And then from that, we can calculate the change in y. So delta x times dy dx gets you delta y. And we're starting at 1, 0. So delta x is negative 0.5 always. So we can actually get this. 1 minus 0.5 will get us 0.5. And then subtract another 0.5, you'll be at 0. All right, let's have some fun. So we're going to plug in 1, 0 into this equation here. If you plug in 1, 0, well, x isn't in this equation, so you just put 0 for y. That's 1 minus 0. That's just 1. And then a half, multiply these two together, you get negative 0.5. So y starts at 0, and you subtract 0.5. Clearly, that's negative 0.5. Now we need to get dy dx at our new point. So at negative 0.5 or positive 0.5, negative 0.5 for x and y. There is no x here, so just plug in the y. 1 minus negative 0.5 is actually 1.5, 1.5. And then we multiply these two together. 15, what is that? 7.5, is that right? I think it's 7.5. Hey Siri, what is 15 times 5?
15 times 5 is 75.
Yes. I am so smart. So, oh, I am not so smart. 0.75. Yowza. Because there's 2 decimal points, so negative 0.75. So what's happening? We start with a y of negative 0.5. We're going to subtract that. So negative half minus 3/4 is negative 1 1/4, negative 1.25. So this is my Euler's approximation. So I would say f at 0 is approximately equal to negative 1.25. Bam! That's fun. That is so fun. Don't you agree, everybody? That is like the funnerest thing I've ever done. That's just beautiful. I erased all my marks. Oh, is anyone bothered by this? Well, too bad. Just kidding. I took care of it. All right, B, find the limit. Now, again, I want to warn you, do not do this. Do not do this because it is very wrong. let's see, the top, let's read some stuff here. It tells us f of 1 is 0. So I want to point out the derivative is 1 minus y. So if that's the derivative exists everywhere. So therefore, this function is continuous. Y, f of x, is continuous. If it's continuous, to take the limit, all you do is find the value at that point. So therefore, some might say, plug in 1 here, because it's continuous. So therefore, if it's continuous, the value of the point is equal to the limit. That's 0. And plug in 1 into the bottom here. That's 0. Now, and then you might say, this is, I'm going to handwrite, this is indeterminate. That is wrong. Dividing by 0 is undefined. You are saying this limit is undefined, and that is not true. It's not undefined. So, to alleviate this problem, you need to write two limit statements. The limit as x approaches 1 of f of x is 0. The limit as x approaches 1 of x cubed minus 1 is 0. Therefore, the limit as x approaches 1 of f of x over x cubed minus 1 is indeterminate. Is it an A and T? Indeterminate? Or indeterminate? I don't even remember. I am so bad, so I'm going to do what all wise people do. You just, indeterminate. Here we go. So, therefore, by the hospital, the limit as x approaches 1 of f of x over x cubed minus 1 is the limit as x approaches 1 of f prime of x over 3x squared. Okay, so what's f prime of x when x equals 1? Well, we have a problem. We have the derivative of, here is f of x. The derivative of that is dy dx. So it is 1 minus y, and you might say, well, I know x is 1, but how do I plug 1 into this when there is no 1? I mean, there is no x to plug it into. But as x approaches 1, we know that y is 0, so we plug in 0. It's 1 minus 0. So that's 1, oh, ouchie. That's 1 minus 0, and it's 3 times 1 squared, which is just 1/3. Bam! That is beautiful. All right, let's keep going. I'm going to erase all my beautiful work here. Yes, that is a beautiful screen. All right, that's good. Let's move on. Just kidding. Some of you guys were mad at me for not erasing every little bit. All right, let's move on. Just kidding. Okay. Part C. Find the particular solution to this differential equation with this initial condition. So we want to find the y. Basically, right here, what function can I take the derivative of and it'll equal 1 minus that function? So hopefully you see it. This is separation of variables. dy dx, ooh, that's beautiful, equals 1 minus y. Well, we need to separate our variables. So I'm going to rearrange it, divide by 1 minus y on both sides. And then the dx is on that side. You would get a point just for doing that. That is so beautiful. Then we integrate both sides. Well, the right side's easy. What's the antiderivative? Now, you might not see it, but there is a 1 there. And the antiderivative of 1 is x. Don't forget your plus c. Now the left side, be careful. It technically is a u sub. Not technically, it is a u sub. So you would make u 1 minus y. Du is negative dy. Do we have a negative dy? Now you do. Haven't said that in a while. All right, so if you substitute everything in the top, all that is just du, and all that is u. So that gets us negative ln absolute u, and then replace u with what u is. All right. So at this point, we need to find our constant c. But we know, we're told this. When x is 1, y is 0. So in our equation, we're going to plug in the point 1, 0. So we're going to get minus ln of 1 minus 0 equals 1 plus c. Well, what's the ln of 1? You all should know ln of 1 is 0. So c equals negative 1. Remember, ln function looks like that. Ln of 1 is 0, just a reminder. So we get a point. Actually, you would have gotten a point for finding these antiderivatives. And you would have got a point, wow, I think for just putting c in this particular year. And then a point for finding the negative 1. Now we plug that in. We take this and plug it in there. Now we have to solve for y. So in this side, we can get rid of the ln if we use base c exponent, but that negative gets in the way. So we're going to multiply both sides by negative 1 first. And that's going to become 1 minus x on this side. Then we are going to use exponent base c on both sides. I'm running out of room, but watch this magic. Yes, watch. It's going to disappear. Magic. So we have 1 minus y on this side. And then here's what you have to realize. This is e to the 1 times e to the minus x. Because when you multiply exponents with the same base, you add the exponents. And 1 plus negative x is that. So we have this e times e to the minus x. We still have to solve for y. Actually, I didn't have to separate that out. We were okay with it. But here is where things get weird. Say I have absolute value of x equals 5. X could be plus or minus 5. So to get rid of an absolute value, I need to make the other side plus or minus that. So I can get rid of the absolute value, but I'm going to get plus or minus e to the minus x. Now that I see this, we don't need to separate the bases out. Let me not do all that. And I think it'll be cleaner. Absolute 1 minus y equals e to the 1 minus x. Now, if I get rid of the absolute value, I get plus or minus e to the 1 minus x. Now, we'll have to figure out the plus or minus here shortly, but now I'm going to subtract 1 from both sides. Then multiply both sides by negative 1. Now, we can't have both the plus and the minus. Here's where our initial conditions come into play. We know we have the 1 comma 0 must be a solution to this. So we're going to plug in 1 for x, and y must be 0. So this is side work. 1 equals, or 0 well, y equals 1 plus or minus e to the 1 minus x. We're going to plug in 0 here. It's going to be 1 minus 1. So 0 equals 1 plus or minus e to the 0, which is 1 plus or minus 1. Clearly, to get 0, it's got to be the minus there. So our final answer, y equals 1 minus e to the 1 minus x. There we go. All right, that was it. That was fun, right? You guys all enjoyed that?